Okay, let's move on to the next feature. In this case, that's the feature about showing the age of creeds. Let's implement this quickly. We can reuse a lot of the infrastructure from the first feature spec, except in this case, it's about showing the age of creeds. Because we want to show the age, we have to create the creed at a certain time. In this case, let's set the timestamp when it was created in the database to 1 minute ago, so that the system thinks it was created 1 minute ago. Then we visit the page of the creeds, and in this case, we don't care about that the content is outputted, like it is done here, but the age. So it should look like something like created 1 minute ago, or something like that. Is that the most ideal string that we want to see here in this case? I think so. We also want to copy again the description. Okay, let's run this test. In this case, again, the integration test is telling us that something is missing. In this case, in line 21, it tells us that it expected to see created 1 minute ago on the page, but the page doesn't contain that. So if we look here, sure enough, that is not the case. So let's look at the template again, and as we can see, the content isn't there indeed. So let's add it here now. I think I want to do this in 2 different steps. First, I'm going to determine the age of the creed. Let's say that should be a number that gives us the age in seconds, and then I'm going to use another function to convert that number into a string that formats the age in the right way. And that's definitely not a responsibility of the model, but let's say a view helper in this case. So let's call that format age. And as you can see, I'm building the code again from the outside in. I'm not building the formatter first, I'm using the formatter and the age method first to get a feeling how they feel to be used. Is it intuitive? Is it the most ideal way of structuring this code base? So with that out of the way, let's run the test again. As we can see, in good old test-driven development fashion, the test is driving our development by telling us exactly what the next step is that we need to do. In this case, the creed class doesn't have an age method. So let's create this method now. In order to do that, I'm going to the creed data model, which is here, and I'm going to add a age method. But wait, let's take a step back and shift gears here for a minute, because now what we do is we create code inside a domain model. Before we do that and create real functionality here, let's create a test for that as well. So let's open the specification for the creed class side by side with the creed class itself. I like doing them both side by side like this. And think a bit about what this age method should do, how it should behave before we actually build it. We are going to do this by just drafting some ideas here. So for example, it returns 0 when given a brand new, or actually 4 brand new creeds. Another edge case is it returns 1 for creeds that are 1 second old. That's pretty clear. And let's take a really big number. It returns 600 for creeds that are 10 minutes old. I think that is enough specification for this method. Let's run the specification to see if it actually works. And it does. It gives us 3 pending specifications. Let's make the first one do something. Running this is pretty easy. We create a creed, and then we expect that creed.age is 0. How does that look like in the spec? What the test tells us makes sense. We expect the age method to return 0, instead we get nil. If you look at the age method, that is really plausible because it doesn't contain any code. So let's add some code here. What's the easiest way to implement this? I think something like time.now, which is the current timestamp, minus the created at time when this creed was created. That should give us pretty much the interval of time in which the treat has been in existence, or the age of the treat. Let's see if it works. And as we can see, we expected 0, but we got 0, something, almost there. So we get a floating point number. Let's fix that by making it an integer. And let's see what that does. And that works. Very nice. Let's make the other specs pass as well. Increase this a bit here so that we can see. For the other specs, we can as well reuse a lot of the infrastructure here. In this case, we want to create that is 1 second old and returns 1. Let's see if that works. It does. Let's do the same the last spec. That should be 600. Excellent. Those work as well. And now that I look at these specs, I think the middle one doesn't really make too much sense anymore. It helped us think through this thing a lot, but I think these 2 specs cover the functionality pretty well. So let's see if those work again. And we are done. Now with the age method fully working, we can go back to our feature spec and see what else is missing here. And as usual, the integration test tells us the next step here. In this case, the format age helper method doesn't exist. So let's create this helper method now. To do that, I'm going to put that in my application helper file, let's say, for simplicity's sake. And again, maybe creating this empty method is fine, but before we start writing any code, any functionality in it, let's write a specification for it first. In this case, there is not even infrastructure for help specifications here, so let's create this ourselves. And as you can see, this is pretty easy. All I have to do is create a folder that contains all the specifications for helpers, and in here an application helper specification. And if I open this side by side with the application helper, the first thing I have to do again is load the test framework from the Rails application, and then I can describe to the test framework which class and which particular method I want to specify here. And again, let's brainstorm first what this method should do. For example, it should return 1 minute ago when given 60 seconds. That makes total sense. Similarly, it should return 2 minutes ago when given 120 seconds. Okay, if we have these two, where does it cut off between 1 and 2 minutes? Let's say right in the middle. So now we have two edge cases we need to check. One is that it returns 2 minutes ago when given 90 seconds, let's say. And the other one is that it returns 1 minute ago when given 89 seconds. Okay, that makes sense. What's the upper limit here? Let's say anything older than 2 minutes is ancient and doesn't interest us, so it returns a while ago when given 151 seconds. That makes sense. In this case, this 120 isn't really necessary anymore because we can just move that up to the upper bound check. So we have this. This can become a 30 now, and then logic dictates that another option up here must exist, something for the immediate, brand new stuff, newer than a minute. So let's say that should just return just now, when given 29 seconds as the upper bound, and then we also need another one for the brand new stuff. So 0 seconds. I think that overall is a pretty adequate description. Okay, I think this is the first time somebody actually thought this through in such detail. So before I'm moving forward with implementing this, I'm actually going to take this now to the product manager and the product owner and show it to them and get their okay from this. So let's do this now. Let's say it's 2 hours later and I'm back. And the product managers with their incredible product vision and product perspective have actually not only found an inconsistency down here, they also want to change it slightly. So they said, let's change this to a 30. And then apparently this needs to be a 31, this needs to be a 90, this needs to be a 91, and this is okay. What this means is we have actually now pivoted and changed our product without ever having written a single line and without ever having to change a single line of actual application code. How awesome is that? That is possible because I had a tangible specification. So with this fully verified and consistent specification in hand, we can finally build the code. In order to do that, we run the spec first. Application helper spec, and we get 5 pending specs. We are going to implement this in a series of really nice red-green cycles. Let's start with the first spec. Implementing this is super easy. We're calling format age with the argument 0 and expect it to return just now. Let's run this. The test gives us the first thing that we need to fix. In this case, we provide an argument to format age, but format age doesn't expect one. So let's adjust that and run the spec again. Now we get that it actually returns nil when it should return just now. Let's make that work. In this case, we use the simplest possible implementation because there are more specs coming. And that works. Let's make the next spec work. We can reuse parts of the first spec. In this case, we give it 30, and we still expect just now. That works as well. Awesome. On to the third. In this case, we give it 31 seconds, and we expect 1 minute ago. So now we have a red test again, which gives us a reason to write some code. Let's make this work. That could be something like that. Let's see. Not quite. As they say in computer science, there are only 2 hard things: cache invalidation, naming things, and off-by-one errors. We have had one of those, and it works. I think you get the gist of this. I'm going to finish the remaining specs off screen in just 1 second. Okay, I finished all the specs and they're all passing now, as you can see in the terminal. And the code is kind of the incremental way that would have resulted if you do this. Now let's run the big feature spec again and see where we are. As the spec is telling us here again so nicely, there's a little bit of a wording mismatch. The page is expected to contain created 1 minute ago, but it only contains 1 minute ago. The created part is missing. Let's add that to the template. Here's the template, and if we had created and run the spec again, it shows us that everything works now. Okay, are we done now? Not quite. Let's look at this helper that we wrote again. This part here contains a ton of if and else if clauses, which doesn't really smell too good to me. And here these tests, they all are pretty much exactly the same. The only way in which they differ is these numbers and the expected text. So let's try to dry this up a little bit. Let's look at the format h method on the right here first. What this method does is provide human-readable descriptions for certain ranges of input data. Let's try to express that intent a little bit more directly in the source code. In Ruby, this could look something like this. Let's see if it still works. Apparently not. And the unit tests not only tell us that something is broken, they also tell us exactly how it is broken. For example, when we give it the number 31, it should output 1 minute ago. Instead, it got just now. Let's take a look at the code. Of course, the just now range should only go till 30. And then the 1 minute ago range should start at 31. Let's see if that fixes this issue. That works. So let's fix the other lines in a similar fashion, because I saw some other tests broken as well. Okay, let's see where that takes us. Everything works now, awesome. As we can see, unit tests not only help us write code better and faster, they also help us while we refactor and maintain it and keep it in the best possible shape. In order for them to be able to do that, they need to be on the same level of code quality, abstraction, and expressiveness as the production code that they are specifying. Let's look at our situation here. Our production code is at this point pretty concise and expressive. On the other hand, the specs are still pretty low level. They contain a ton of copy and pasted code, and I'm not convinced that a developer looking at these specs the first time gets immediately what rather simple thing the format h method actually does. Rather, they will have to read through almost an entire page of specifications in order to figure this out. So, while we're at it, let's refactor our specs as well. As we've discussed before, what the specs really only do is call the format h method with certain input data and then compare the result of that against a certain expected value. One way to do that in Ruby is through a hash data structure, which maps input into the method under test to output in that situation. With this test data in our hands, we can now loop through it and in each iteration call the format h method with the current key and make sure that the result of that operation is the expected value. And if we run our tests again, they still work. To finish this off, let's run all the specs again. Okay, at this point we are done with the feature and will check our changes into a version control system. The tests that have guided us so well during the development of our feature keep protecting it for the lifetime of this project. To give an example for this, let's say a few weeks later another developer is fine-tuning the design of the template. Let's say over time more features have been added and the template has evolved into this. And then somebody else refactors the frontend, and after manually resolving if we merge conflicts, our template looks like this. When I check these refactorings into the source code repository, the CI server will automatically run all the tests. And guess what? Indeed, showing the age of creeds doesn't work anymore, because there's a bug here in the template. Good thing that our specs caught this issue for us before we even merged these changes into the main code line. Not to speak, shipped this stuff to production and made complete fools of ourselves. A regression bug has been prevented thanks to automatically verifying changes against existing specifications. Okay, let's fix this bug and make sure everything works. Let's review what we did in the screencast. We built another feature, guided as always by a feature specification, which are also known as integration tests. Again, we had the pleasure of using our code before we even created it, and built the app from the outside in. This made sure that our code base is easy to use and intuitive to understand. This feature required algorithmic code, so at the appropriate times, whenever the feature spec told us to, we dove deeper into the code layer and TDD'd whatever classes and methods were needed there. The lower level unit tests for these methods helped us think through all the different use cases for them. They even helped us verify and improve details of our code's behavior before we even created it. This made those changes extremely fast and cheap. Writing these tests was always extremely quick and easy. Each time a small unit of code has been completed, we went back up to the feature spec layer to determine the next step for us towards making the feature work. The overall development felt like it is on tracks, on a straight line towards finishing the current feature. Never did we take any unnecessary detours, and never did we not know where we are or what's next. Instead, the feature spec always told us the next thing to do. And after we were done, we were able to change and refactor the code to our heart's content, while always being sure that it still works as intended. We also looked at how our specifications kept ensuring that existing features keep working as intended, even when the underlying codebase changes dramatically.